Good to know. So today I'm going to be talking about speaking for thinking, understanding the link between cognition and speech. But first, I want to put in a plug for the Spark Society. This is a scientific society for cognitive scientists, linguists, psychologists, neuroscientists that tries to increase the number of underrepresented ethnic minorities in cognitive science. So if you have any interest at all in that, we started this up a couple of years ago. Head to this website or send me an email. We have a lively Facebook discussion group, and it's open to everyone, both underrepresented groups and allies. All right, so I'm going to talk today about prosody, and I'm used to talking to psychologists, and so I imagine talking to linguists, you guys already know all this stuff, but a rough definition of prosody is not what you say, but how you say it. So it can include things like metrical structure, rhythm, intonation, changes in pitch up zero, pauses in speech timing, and in languages like English, pitch accenting and emphasis. And so there's a lot of linguistic information that can be conveyed in the prosodic signal, right? So where you place an intonational boundary or pause in a sentence is a difference between a lie like "you have a body like Adonis" and the truth, "you have a body like Adonis." That's the one joke, so I imagine you're all screaming with laughter. So prosody is sort of interesting, right? Because it conveys what I like to think of as metalinguistic information. So it's linguistically structured itself, but it's mapped onto other levels of linguistic representation. And so an astute listener can get lots of information about a speaker's beliefs, goals, and intentions, but also information about syntactic structure, semantic structure, semantics, or pragmatics, and discourse structure from the prosodic signal. And the claim I'm going to make today is that prosody is influenced by all these different linguistic representations, things that folks have called linguistic competence. But I'm going to present some evidence today that suggests that prosody is also clearly influenced by the cognitive machinery of language production and social and communicative contexts. And so without understanding all of these things simultaneously, we're not going to be able to develop a full model of prosodic representations. And ultimately, I'm going to argue that we can't decontextualize prosody. The context in which it occurs is really important in terms of the factors that lead to its production and how it's interpreted. So I'm going to talk about three prosodic phenomena that we've studied in my lab that all sort of point towards this claim that I'm making. The first is a series of experiments where we've been interested in speech rate and word duration and its link to planning processes. And then I'm going to talk about contextual and communicative context and show some data suggesting that speakers provide better acoustic phonetic cues to things like pitch accenting and emphasis in more engaging contexts. And then finally, if we have time, and I don't think we will have time, but I'm an optimist, I'm going to argue that listeners' perception of prosody is partly driven by expectations and not just the bottom-up signal. All right. So, and I do want to add that if you have any questions, feel free to jump in and ask or throw them in the chat. All right, so let's talk about word duration and production. So imagine you have two individuals, person A and person B, and person A says, "Who took your man?" Person B might say, "Jolene took my man," right? And so we're in Nashville, so we're all Dolly Parton stands. So everyone sort of agrees that if you're going to emphasize a word in the second sentence here, it's going to be Jolene, right? And it has something to do with the fact that it's the answer to the question. And so where people disagree is sort of how to formalize that fact, that intuition that Jolene is not only pitch accented, but extended in duration. So there's a class of theories that basically argue that this is done for the listener, right? That there's grammatical links, there's sort of mappings between focus and pitch accents, mappings between pitch accents and pragmatics that a listener knows when they learn the language and uses that information to sort of retrieve that information. There's other versions that are sort of more information theoretically focused that argue that, when there's sort of high information in a sentence, a high information word, like an answer to the question, here it's Jolene, then it's going to be extended in duration. If it's given information or low information, it's going to be reduced. Okay, but all of these are sort of predicated on this idea that pitch accenting word duration is sort of something that's driven by the listener. There's another class of theories that argue that it's something that's primarily for the speaker. And so this is an argument by Jason Kahn and Jennifer Arnold, Belota et al. And I've even argued this in the past, that the reason that Jolene, and here I'm really talking about word duration, the reason Jolene might be lengthened here is not just for the listener, but it's actually providing the speaker with time to access and produce the word itself. And the more general argument is that we can look at the durations of words and speech timing more generally, and use those as sort of a window into cognition and a window into the planning production processes. All right, so just to kind of dig down into one version of this idea, this planning idea, this is sort of a cartoon of how speech planning works. So at the highest level, you've got to plan your message. Then you've got to pick the words that you want to produce and formulate a syntactic representation that creates a grammatical sentence. And then finally, you have to select and encode the relevant phonemes, acoustic features, and finally articulate. Now, there's one theory proposed by Jason Kahn and Jennifer Arnold, is what's called the facilitation reduction hypothesis. And the idea here is that when facilitation happens at any of these levels, that's going to play out on the duration of the word here, Jolene, right? So if message planning is easy, if lexical access is easy, if accessing the sounds is easy, you're going to reduce the duration of Jolene, all right? But this actually has never made sense to me. And I think it sort of raises sort of a puzzle, right? So if you as a speaker have already begun articulating a word, that means you've already accessed it. So what possible benefit could lengthening or reducing it provide, right? So you've already done the message planning and the lexical access. So why would that affect word duration? And so we've done some studies sort of arguing that, in fact, the link between word production and word duration is much more circumscribed, that in fact, it's really mostly the processes of phonological encoding that influence duration of a word, so during the word, but higher level planning like lexical access, syntactic formulation, message planning, all that good stuff, primarily influences speech rate and duration before the word. All right, and so I'm gonna present a bunch of experiments that sort of point in this direction. So rather than having sort of general facilitation leading to word duration effects on Jolene, really we can divide up our, our planning process into two chunks, things that affect the duration of a target word like phonology and articulation, and everything that happens before that, like message planning and lexical formulation. So let's turn to evidence for phonological effects first, and then we'll talk really briefly about effects of higher level planning. So why would priming of a word lead to reduction? The argument that I'm going to make is that basically you need time. Speakers need time to order the sounds of a word, such that when doing that phonological encoding is more difficult, you need more time and you lengthen the duration of the word. But if a word is primed or repeated in a conversation and reduced, you need less time, so you reduce it, right? So that's the general argument that we're making. And there's some evidence out there in the literature that points in this direction. So there's some work way back in the 90s by Sebald and Dell. And what they did was they had subjects come to the lab and they gave them pairs of words. And the subjects had to repeat those words as quickly as possible for 8 seconds. And what they found was that when they picked words that overlapped initially, like pick and pen, people were slow. They were slow to do these repetitions. But if they selected words that overlapped finally, like pick and tick, they were faster. And you can kind of try this and get a sense of this asymmetry, right? So pick, pen, pick, pen, pick, pen, pick, pen is harder than pick, tick, pick, tick, pick, tick. And so they argued that the reason you get this difference has to do with phonological encoding. And more critically, it has to do with the fact that the system must be serially encoding the sounds associated with the word, right? And so they sort of created a conceptual model. It's sort of based on Dell's 86 interactive model that was actually implemented. This model was never implemented, but was argued to explain this effect. And so the idea is that for initial overlap, if you're saying pick and pen, so in the model, I should take a step back, you've got nodes for words like pick and pen, and these are connected to phonemes. And you've got interactive activation between these two layers, so that pick sends activation to this phoneme, pa, and then that's going to send activation back to pick. And so if you're trying to select pick, activation is going to go to the pa and the vowel here, and activation from these nodes are going to go back to pick and back to pen. And what's going to happen is that you're going to get sort of competition between these two because they're both getting activated from the same set of sounds at the beginning of the word. And that's going to slow you down over the course of the word until you finally get out the right word pick. In contrast, for final overlap, if you're producing pick, you don't have overlap until you're about halfway through, until you're to the vowel, right? And the fact that that overlap comes late has consequences for the entire word. And so what it means is that you get less competition here than you do here because the overlap happens later. But critically, this only makes sense if you're picking the sounds one at a time. If you're selecting all the sounds at once, you don't get this asymmetry in sound selection. So we decided to see if this general theory was right. And our goal was to see whether serially encoding the sounds of a word actually leads to duration differences. And this is work with Andres Pujo-Lugo, who's a student of mine. He's now an assistant professor at University of Buffalo in New York, and Dominique Simmons, who is an RA and now is a data scientist. And our overall goal was to create a simple recurrent network that produced overlapping compounds like layout layover and outlay overlay. And we train the model up on producing these things and see where the model makes errors. And then we have speakers produce these same words and see whether speakers slow down at the same points that the model has difficulty. All right, so that's the overall goal. Do speakers slow down at the points of complexity predicted by the model? And so we designed a simple recurrent network that was based roughly on Del Giuliano and Gavinji, where you've got lexical nodes. These feed into a layer of hidden units, which feed to an output layer. And then the hidden units in the output layer get copied to these state layers. And the advantage of using a model like this is these state layers act as a memory to test our hypotheses about the serial order effect, right? So you're trying to say a word, the hidden units receive activation not just from what you're trying to say now, but what you've said on the previous cycle of the model. All right. An additional advantage of using an SRN is it allowed us to test these serial order effects with minimal assumptions about linguistic structure. So, obviously we're interested in the linguistic structure and planning processes, but we really were, for this, interested in seeing whether serial order matters in terms of error. So the way the model worked is we've got some nodes for our compound words like layout and layover. I'm trying to say layout. That node's going to get activated. It's going to send activation to the hidden units. And after training, it'll send activation to the output. And the output layer is simply the morphemes that are part of the compound. And so if all goes well, it'll pick the first morpheme of layout. And then for the next cycle of the model, the output activations and the hidden unit activations are copied to these state layers, such that on the next cycle, select layout again to keep on producing it. Activation is going to be fed from the hidden units, from the lexical, and these two state layers. And if all goes well, it'll select out, activations get copied, and then on the next cycle of the model, it'll hopefully say, hey, I'm at the end of the word. All right, so that's what the model was trained on. And like I said, I didn't build any suspense here. This is sort of the sum squared error. So the parts of the word that the model had difficulty with. On the y-axis, we have sum squared error. So the higher it is, the more error the model experienced. This gray line here is initial overlap, layover layout. This black line here is final overlap, outlay, and overlay. And this is the error on the first morpheme, the second morpheme, and the word boundary. And what we generally find is, whoops, we find that initial overlap leads to more error than final overlap overall, and that overlapping morphemes elicit less error than non-overlapping morphemes. And that piece is not that surprising, right? The overlapping morphemes were more frequent in what it was trained on, and so the overlapping morpheme lay, which is going to be on the first morpheme for layover and layout, and on the second morpheme for outlay and overlay, are going to be really easy for the model to produce. All right, so this by itself isn't super interesting. The real question is whether speakers slow down at the same points at which the model predicts high levels of errors. And if they do, it suggests that this serial ordering process may be underlying some of the duration effects that we see more generally. And so we had subjects do what I like to call, this is what we call the world's most boring experiment, because participants really didn't like this. It was a repetition task. They had to come in and produce these overlapping compounds as quickly as possible for 8 seconds. And we had a lot of them. They had to do this for a while. And we had an initial overlap condition and a final overlap condition. And we tried to select compounds that overlapped, like layover and layout, but were also reversible, such that they made sensible words like overlay, outlay. You can see the mapping here. And that was to kind of roughly control what's going on acoustic phonetically between the conditions. They're not matched perfectly, but it gives us an approximation. The other tricky thing, so those are tricky to come up with. And I just like to have a moment of silence for the fact that it was hard to come up with compounds that were reversible and overlap. There's like 6 or 7 of them in English. And we're interested in their word duration. And lots of factors go into the duration of a word, right? It's not just the phonemes in it, but it's imageability, it's frequency, all sorts of things. So the data I'm going to show you is not the raw durations of layover, layout, overlay, and outlay. It's the difference between layover in this overlapping context and layover in a baseline condition where it appears with a word that it doesn't overlap with, right? So that way we can control for the properties of the word, but still see the overlap effects. All right, so I'm going to be showing you different scores. Okay, and so Kai is asking, maybe this was a question that came out earlier about information structure like contrastive accents. I'm going to return to this question maybe a little bit in the second part of the talk, Kai. So if you want to,
that's absolutely fine. Don't
okay.
You worry, Duane. Just go ahead, please.
All right. Okay, so here we're looking at duration, and so this is the data from the model, right? You've already seen this, and the question is, will speakers slow down at the same morphemes that the model predicts error? And it looks pretty close, right? So we see that initial overlap generally is the word durations are longer than for final overlap, and we get this nice interaction where, as predicted by the model, people are quicker on the most frequent part of the compounds and slower on the non-overlapping, less frequent part of the compound, suggesting that both within and between differences between these words can be partly explained by the fact that the model is doing serial ordering, and presumably people are doing serial ordering of the phonemes in the words. So one thing you might be wondering, after sort of processing what's going on here, is, hey, wait, this task is really weird, right? You're having people come in and just produce these things as quickly as possible for 8 seconds. Maybe we're sort of artificially inflating these duration effects by having them rapidly produce these words. This is not anything like normal language. And so we tried to come up with a task that at least somewhat better approximates a normal conversation. So subjects come to the lab and they're presented with a display like this one, where they're given 4 objects, and one thing shrinks and then another object in the display flashes, and they just have to describe the event. So they might say the beetle shrinks, the beaker flashes. Now, what this allows us to do is to manipulate the overlap between our prime here, the thing that's shrinking, and our target word here, the thing that's flashing. So we have an initial overlap, beetle, should lead to more lengthening of beaker than something that overlaps finally, like speaker and beaker. And this is work by Loretta Yu, who was a RA in my lab, who's also now a data scientist. And so the question is, do we see these duration effects in something that better approximates normal conversation? And it turns out we do. So we had two control conditions where our target was repeated. So the beaker shrinks and then the beaker flashes, and a condition where beaker is completely new. So the apple shrinks and the beaker flashes. And what we find is, this is not surprising. When beaker is new, it's longer than when it's given. But when there's initial overlap, here we're calling it cohort, there's even more lengthening. And there's a bit less lengthening, significantly less lengthening when there's final overlap, beaker. All right, so this suggests that even in sort of this non-weird repetition task, we can see these sort of interference effects between words that might occur in different clauses. So this is sort of a proof of concept. We've seen that these serial encoding of phonological information can affect between word durations and within word durations. And I think this sort of speaks to our earlier hypothesis. Reduction and lengthening is linked to the complexities of phonological encoding. And this makes the interesting prediction that repeating phonemes will actually lead to reduction even if lexical and message level information changes. And so we decided to test this by looking at homophones. And so this is work with Loretta and Cassie Jacobs, who was a former student, who's going to be a faculty member at University of Buffalo. And the prediction here is that if you produce pie, if I say the pie shrinks and I'm referring to the pastry, and then I say the pie flashes and I'm referring to the mathematical symbol, we should still see reduction, right? Because we've primed those phonological encoding processes, they should be easier to get out because there's this shared phonological representation between these two words, even though lexically they're different, semantically they're different. There's a great question about stress here. I will return to that because that's going to be relevant a bit later. That's okay. So in this experiment, we had our target word again is pie, the delicious pastry, and it was either repeated, completely new, or preceded by its homophone. And looking at the duration of the word pie, what we see is that, again, when it's repeated, it's given information, it has the shortest duration. When it's new, it has the longest duration, and our homophone condition sort of appears in between. So we get reduction from something that's completely both phonologically and lexically new, but not as much reduction as when the whole thing is new. And I suspect that the reason this bar is not down here is that you still have things like pitch accenting, probably an H star, if you like Toby, occurring on here, and this reduction is sort of riding on top of that sort of discourse-driven pitch accenting. But that's something definitely we're interested in figuring out. All right, so I've talked about some initial evidence suggesting that phonological and articulatory information seems to affect duration on the target. Now I'm going to present some preliminary evidence that we have that other types of planning affect the timing before the target. And so in this experiment, we decided to directly compare semantic overlap and phonological overlap in sort of the same kind of shrink, it's interesting speech error, shrink flash priming experiment. And so we had a condition where there was semantic priming, the apple shrinks, the orange flashes, and an experiment where we had phonological, I don't know if we want to call it priming, but overlap. The candle shrinks and the candle flashes. And looking at reaction time, so this is the time between the event of flashing and production of our target word orange here and camel here, what we see is that when there's a semantic relationship between our prime word and our target word orange here, we get a reduction in duration, right? So this is when it's apple versus an unrelated control. For phonological priming, we don't see the same type of effect. All right, but looking at the actual duration of the target word itself, we get a very different pattern. So here we get very small difference between our unrelated and related conditions for semantic overlap. But on our phonological overlap, what we find is that phonologically related words like candle and camel lead to, again, longer duration than unrelated words, right? Okay, so this is like a replication of what I've shown you in the previous tasks. But what we see is that, most of the action for semantic relatedness seems to happen before the word, and most of the action when it comes to phonological relatedness seems to happen on the actual word itself. So phonological encoding seems to influence speech rate during a word. Higher level planning seems to be linked to speech rate before a target word and seems to take the form of facilitation. We don't actually see evidence for this facilitation reduction hypothesis where making things easy at every single level seems to lead to shorter word durations. But I do want to have add a disclaimer that I don't want to say phonological encoding is the only factor in word duration. I mean, obviously there's lots of things that influence duration. Things like frequency, plausibility, properties of the phonological representation of the word itself. But phonological encoding does seem to play a role when it's linked to these production effects. And Lauren asked, did we look at the following word too? I want to say we did, but I don't remember actually what the outcome of that was. But that's a great question, right? Because you'd want to know, because if it's sort of phonological encoding, you probably wouldn't expect spillover, right? You'd expect maybe higher level effects for the word coming afterward, but not those phonological encoding effects. But that's a great question. All right, so we're pursuing this question in a bunch of different ways, trying to sort of nail down what serial phonological encoding actually means in language production. And one interesting thing that we've found is that we only seem to see reduction when we have a repeated word, when the word has been articulated aloud. So we ran an experiment where subjects had to describe a hat that shrinks and a hat that flashes. But in one condition, they were told to only mouth the prime sentence, the thing that shrinks. So they'd say shrinks. So they do everything except actually sort of produce the word. And in the other condition, they were asked to vocalize it. And what we find is that reaction times, so the time between the hat flashing and articulation of hat, is facilitated in both of these conditions, but we only see reduction of the word hat itself when they've said the word out loud. So this might play this may point to a role of auditory feedback potentially in phonological encoding, such that if you don't actually get that feedback, you don't actually hear what's being said, then you actually don't get the priming effect. We've seen the same kind of mouthing effects when it comes to interference as well. So if say the camel shrinks and then the candle flashes, then when camel is mouthed rather than articulated out loud, you don't see lengthening of candle, but if it's said out loud, you do see lengthening of candle. Again, maybe pointing to this auditory feedback possibility. And this is where we get to Gada's question about metrical structure. So this is work with Brett Myers, who's now faculty at University of Utah. He was a former student of mine. We manipulated the metrical overlap between the prime and the target in addition to phonological overlap. So we'd have primes like the camel shrinks, and then they'd say the candle flashes, or the canoe shrinks, and then the candle flashes. And so in the second condition here, there's a mismatch in the metrical structure. And interestingly, compared to a baseline condition, we get lengthening of candle in both of these, but we get more lengthening in the metrical and phonological overlap condition. And if we just have the prime overlap metrically, but not I want to say phonologically, that's not a word. Phonologically, then we don't see any lengthening at all. So it doesn't seem that metrical overlap in and of itself leads to this kind of interference effects. It has to be paired with phonological overlap. And so this might point to maybe some kind of acoustic phonetic matching, like if the duration of the vowels match more, then you're going to get more lengthening. this opens up a number of interesting possibilities of what's actually going on in phonological encoding. So all of this together suggests maybe there's a role for auditory feedback, and maybe it's sort of grounded in representations that are acoustic phonetic. So these are sort of questions that we're asking to understand what the mechanisms are that guide the ordering of a word sound. All right. I'm going to switch gears a little bit, and in the remaining time, talk about speakers providing better acoustic phonetic cues to pitch accents in more engaging contexts. And this is work again with Andres and Joe Toscano, who's a postdoc of mine. And I should be able to get through this quickly. So there's a couple of big questions in prosody. I feel like this won't be very controversial. Some of the things I might say in a minute might be controversial. So we know that acoustic prominence, pitch accenting, emphasis conveys important information, pragmatic information about information and discourse structure, right? And so the two questions I think that keep people who study prosody up at night is, how do we characterize the discourse pragmatic context in which prominence occurs, right? So how do we formalize a theory of the relationship between these linguistic representations? And the second question is, what are the acoustic correlates of prominence? So how do we know that we hear a pitch accent when we hear one? And I would say we don't have great answers to these questions. The field is kind of a mess. And it may be due to different methodologies used by different research groups. There's roughly two different strategies. One is to use lab speech and referential communication tasks. And those are the kind of tasks that I've spent the entire first part of this talk talking about, where you bring people in the lab, you get them to say something pretty specific, and then you see what they do. You see where they put pitch accents and you measure them. And the nice thing about this is you get fine-grained acoustic phonetic control. But usually, if we're asking people to describe things that are shrinking or flashing, it's not a super engaging task, right? There's no goals, the communicative stakes are low, and the discourse contexts aren't really that compelling. Another approach is to look at natural speech and speech corpora. And this is nice because you've got like nice natural goal-oriented conversations. But as a psychologist, I like experimental control over the content, right? So it's a little bit messier than what we're used to dealing with. And I think maybe these two different approaches have contributed to some extent to basically large disagreements about what the discourse constraints and acoustic correlates of prominence are. So different labs think that different things matter for determining pitch accenting. And so the hypothesis that I'm going to float here is that maybe unlike other aspects of linguistic representation, maybe the context really matters for prosody. Maybe speaker engagement, communicative stakes, goals, the presence of a listener are all critical for conveying prosodic information. And so maybe that explains why we get such differing results across different tasks and different labs. So in this experiment, we developed two different tasks to explore speaker engagement, but we did the same discourse manipulation for the words that we're measuring, our target words for both tasks. And so the discourse manipulation was all centered around subjects describing color patches. And we sort of created these discourse contexts where they may put a pitch accent on our target word that's bold-faced here, depending on what condition they get. So we tried to create a condition where they were likely to produce pitch accents. So where there's some kind of contrast, gray, blue, black, gray, pink, black, right? So everything is matched, except you got this contrast for the middle color here. A novel condition, red, blue, green, gray, pink, black, where everything is new. And then a no emphasis condition where everything's given, gray, pink, black, gray, pink, black. Our second manipulation was a manipulation of speaker engagement. And we manipulated this by creating a context where the communicative stakes were really low and one where they were really high. And I'm going to go through the low communicative stakes experiment first. And in that experiment, basically, we had subjects come into the lab, we give them these colors, and they just describe them. And they're given in pairs. So first they get the first set and then the second set. So this is what that sounded like. And I apologize, my neighbor is having yard work done, so hopefully you can still hear.
Red, gray, white. black, blue, brown.
All right, and then they get things like, okay, next trial, right? And so they did this for 40 minutes, right? So really, this is not a communicative task at all. We really tried to create an extreme. The more communicative task was doing the exact same color description, but in a context where the communicative stakes were higher. And this was done using the sort of gaming platform, Minecraft. For those of you who don't have middle schoolers who are really into this, I do. It's basically sort of like a Lego world that's sort of easy to kind of create and program, and people create different worlds. And so what we did was we had two players having to work together to solve puzzles to navigate through this dungeon. And essentially we tried to create a more engaging version of a referential communication task. And in this more engaged condition, each participant in the real world was in a different room in the lab, but they were connected through the same server and talked to each other through a headset, and we recorded their conversation. And so we had our critical trials where they had to describe these color patches, but we intermixed these with sort of filler trials where they had to sort of solve a puzzle to move together into the next part of the maze. So they're in a maze, they can see each other through a window, so they're not in the same room in Minecraft, and they have to kind of convey information to work together to solve a puzzle to open the door to get to the next level of the maze. So this is just an example of a filler trial.
There's a bunch of glass down. Oh, it says send a train here. Okay. There's a little like train beneath me, and I'm just watching it go in figure eights. So could you hit the green switch?
Okay, so she hits
Okay,
green.
cool.
All right, so she hits green, the train goes through, and then the doors open up. All right, and you can see she's in a different room than he is. All right, so in our critical trials, player 2 here is the person we're really interested in recording. They're going to see color patches appear, and they have to convey that information to their partner to hit the right combination of colors to open the door. And again, our overall question is, are they going to produce better, more discriminable acoustic phonetic cues in this context compared to our other task? And this is, I'm going to be playing you player 2 describing these colors.
Blue, white, and brown. Okay, green, gray, pink.
Okay, and then her partner does it, and then the door opens up.
And pink.
All right, so I'll skip this video. This is just the person hitting the buttons. And so I'm going to show you, again, I'm going to show you the target, the acoustic cues, pitch accent, F0, duration, and intensity. Those are just 3 that we selected for this word pink here in these 2 different conditions, in both this task and in the less engaging task. All right, so this is the duration results. So on the y-axis, we have duration in milliseconds. On the left here, we have that low engagement task, the subject just describing colors on a computer, and high engagement task. This is our Minecraft task. The gray bars are the bars where we expect more pitch accenting. We've got our contrast condition and our novel condition, and then our given condition is the darker colors here. And basically what we see is, in both conditions, we still see these duration effects. So even when you're just naming colors for 40 minutes, you're still likely to reduce the duration of things that are repeated, which I think is interesting, and I think is probably related to the phonological encoding effects that we've seen in the prior part of the talk. Although these effects are larger, there's a significant interaction in the high engagement condition. If we look at intensity, we see that there's not much going on other than that people are generally louder when they're playing Minecraft. The interesting measure here is looking at pitch range. So this is the difference between the maximum F0 and minimum F0 on our target word. And in our low engagement condition, we don't see an effect of information status. but in our high engagement condition, we do, and this interaction is significant. And so I think this is really interesting because in sort of the normal boring referential communication tasks that we run in our own lab, we almost never see effects of F0 that people talk about in the literature, talking about, say, Toby contrasts for pitch accent type. But we do see them in a case where people are actually communicating and actually talking to someone in a task where the communicative stakes are really high, suggesting that the presence of the cue might be determined by the context in which it occurs. So to summarize, prosodic cues seem to be highly dependent on the context and the discourse goals of the interlocutors. And we have the tools to manipulate information importance to build a more comprehensive theory of prosodic prominence. There have been times in the past where I've presented this and people are like, well, yeah, obviously, if you have people playing Minecraft, they're gonna just be better at communicating and produce better prosody than if they're not, right? But my response to that is, yes, that's the point. So we need to be designing our experiments like Minecraft and not like the typical referential communication task. And so the nice thing about Minecraft is that it's easy to program in. My middle schooler does it. And so you can create these sort of nice controlled contexts where we can look at prosodic cues, all kinds of acoustic phonetic cues, actually. Great question. Did the low condition also include an interlocutor? No, it did not. So we really wanted to make that condition as uncommunicative as possible. We did run a follow-up where we did that same task, but with interlocutor, and I believe the effects, we saw sort of better usage of these acoustic phonetic cues to pitch accenting, but not as high as the Minecraft condition. So again, I think all of these factors kind of add up to a person either producing these cues or not. Okay, so since we are running low on time, I'm going to not go into the third part and just leave it here. So I presented some data suggesting that speech rate and prominence is related to language production, partly, and that speech rate at different points in an utterance is influenced by different stages of planning. So if we want to sort of build these comprehensive theories of pitch accenting and understanding how all the different acoustic phonetic cues that correlate with pitch accenting happen, it's important to have both sort of a performance and competence theory of what's going on when we're producing prosody. And in the second part, I tried to argue that the acoustic forms of prosodic events are at least partly modulated by goals of the interlocutors. And if we want to sort of get agreement across labs, if we want to sort of cut prosody at the joints, I think we need to sort of take an approach where we're actually looking at prosody in sort of more communicative contexts. So the takeaway is we can't decontextualize prosody. Linguistic mappings between syntax, syntax, discourse, semantics, I think I got everything, and prosody are obviously very important, but we also need to think about performance and planning constraints in social and communicative contexts. All right, thanks to all my collaborators, the many research assistants in the lab who had to do lots of coding and transcribing, and our sources of funding, and thank you, the audience, for listening. Thanks. And I'm happy to answer questions.
Fantastic talk. Sorry.
Yeah.
You answered my questions already.
Okay. Yeah, so I did want to say that, things like contrastive accents are obviously playing a role in prosody, but in addition to all of these other things.
Yes. Thanks a lot, Duane.
Any questions? How about, let's see, Christos?
Okay, mine is actually quite a simple one. And at the very start, thank you very much for a very enlightening talk. At the very start, you said something along the lines that prosody maps onto language, onto levels of linguistic description. And I'm just wondering whether you want to, to tell us a bit more about that, or might it be the other way around?
So what do you mean by the other way around?
you know, whether the language actually, the information structure actually maps onto prosody.
Oh, I see what you're saying.
Mhm.
Yeah,
Or
I think,
some kind of aspect of prosody.
yeah,
Exactly, such a multifaceted.
yeah. So I guess I would say, I guess all I was trying to say there was that there are these sort of mappings between, you know, the prosodic representations that a language uses and things like pragmatic semantic discourse representations. The directionality of those mappings and the form that they take, I think, is super interesting. Didn't tackle those in this talk, but I think that's sort of an open question for the field, right? So there's lots of theories about how this works, but I just sort of wanted to acknowledge that those mappings exist, so that, you know, any prosody researchers in the audience didn't throw virtual tomatoes at me.
Okay, thanks.
Yeah. Gada, did you have your hand up first, and then Lawrence?
Thank you. That was very, very interesting. I just wanted to go back briefly to the stress issue that I pointed out.
Mm-hmm.
I was just thinking about your comparisons and the fact that if you're comparing durations in disyllabic words with a trochaic stress pattern, then you're likely to find a bigger difference in the first syllable than in, for instance, the cur of beaker and speaker. I think that was what I was referring to.
Yes. So I guess what I would say is, so in all of our experiments, we're always comparing the target word to itself, just preceded by sort of different primes, right? So it's true that the primes themselves differ in a number of different ways. And so, you know, the only hope, you know, the hope is that we have enough items that, you know, that kind of washes out. But it is true that, the later experiment that I talked about, where we saw effects of metrical overlap between the prime and the target, suggests that, you know, we need to go back and carefully think about those items' metrical properties, the metrical properties of the primes, because those might have an influence on what's going on in the target word. I don't know if that answers your question, but this sort of issue of metrical structure is really tricky, and it's something that I've been sort of thinking a lot about, sort of moving forward with these types of studies, because it's hard to control. Yeah. Thanks. Lawrence?
Hi, yeah, that was great. Thank you very much. It's, as someone who's done quite a lot of lab studies looking at timing effects, it's reassuring to see these things like the effects of prominence, contrast, accent coming out in these nice real world type scenarios. And it was interesting. So I had a couple of questions related to the contrast between the sort of Minecraft setup and the basic repetition setup.
Mm-hmm.
One is you saw the effects of things like contrast in both conditions, but everything was overall longer. Was there an interaction between the conditions and the scenario?
Yeah, so let me see if I can bring this back up. Whoop, part of the talk I didn't talk about. Yeah, so we did get interactions here. So yeah. Our sort of contrast and novel condition had longer duration in our high engagement than in our low engagement condition. So the difference here is significantly smaller than the difference here. Yeah. For F0, we also get the critical interaction, suggesting that the task matters. For intensity, there really wasn't a difference at all between the conditions in either type of task, which frankly I was kind of surprised by, because usually in our typical referential communication task, we do see effects of intensity, and we didn't at all here, which I was puzzled by, but yeah.
Yeah, and the contrast between that and the timing results leads me on to wonder how much of the timing the overall timing difference is due to just a general rate effect rather than a specific sort of accent effect?
Yeah, that's a great question. So the question is, in the given condition, or basically in the Minecraft condition, when they were repeating the things, were they just slower on everything?
Yeah.
All 3 words. And I hope I'm not going to say something that's not true. A reviewer asked us this, and I feel like we went back and did like a proportional analysis. You know, instead of looking at raw durations, we looked at the proportion duration of the words and found the same effects. I will say that Joe Toscano, who's a co-author on this, is sort of like the computational contributor, and he and Bob McMurray have sort of a nice model using just sort of, if you look at sort of the means and the variance of different acoustic phonetic cues to phonological categories, you can use that to sort of model the discriminability of the categories. And so he applied the same analysis to this, showing that you can actually model you get higher discriminability in the high engagement task for the specific target words compared to the low engagement task. And so I think that might partly address your question, although maybe not though. It's sort of like a global slowing. Maybe that wouldn't have gotten picked up in the analysis, but that's definitely an interesting question. I apologize that my memory fails me.
No. So I mean, obviously the interaction in itself is also very informative. Can I just ask one other question related to the other condition, or sort of prosaic lab speech one, related to phonological planning? I suppose you're essentially just repeating a series of similar words or a small group of words over time. And I wonder if you see a sort of incremental planning effect. So if you add trial as a variable, does that affect duration?
That's a good question. So we didn't actually include that trial in the models. I mean, and we could also have included within a trial, you know, the individual word in the trial in the model. I don't think we did that. But it's definitely something that we could do. It would be really interesting to see if the interference effects get bigger and bigger within trial and across the experiment. That would be really a cool thing to look at. Yeah,
it's something people ask me about perception experiments quite a lot. Did you look at order effects? Did you look at the effect of trial? And it seems potentially relevant here as well.
Yeah.
I did look at it.
I guess the tricky thing is, you know, I feel like whenever I include those order effects, they never come out, but it's because the experiment wasn't designed to detect order effects, and so you don't have enough power, and so it's all. But in any case, I get asked that a lot too, although not for this study, which is something we should look at.
Thanks.
Lauren. Oh, and I noticed someone asked about the stress on Jolene. It depends on, well, at least in the States, it depends on what region of the country you're from. Sorry, Lauren.
That's where the guitar comes in.
Yeah, right.
Yeah, just I guess sort of following up on Lawrence and yeah, I was wondering whether it would be possible to test the global rate or the difference between low engagement and high engagement by programming a low engagement task into the Minecraft task, and maybe doing it blockwise by having the low engagement before or after the interactive part, whether that could get at the sort of global speech rate properties, or whether you think that would just introduce the same problem all over again.
I think that would be really interesting. It might get at the global speech rate thing. I mean, I sort of have this intuition that when people produce prosody for other people, they're not necessarily making fine-grained distinctions for individual words. What they're doing is turning up and turning down the gain on their speech in terms of how interpretable it is. And what you're suggesting might be a way to kind of probe that. Like if you get, you know, you're playing Minecraft and then you're just describing colors, it'd be interesting to see whether you get sort of overall change immediately, whether, you know, as the boring experiment gets more boring, do things sort of slow down over time? That would be a very interesting thing to look at. And Rory?
Hi, Duane. Thanks. That was a really great talk. Very, very engaging. I wish I could do all my experiments in Minecraft now. I'm designing experiments, honest. That's what I can tell everyone. I had a quick question about the ideas you presented fairly close to the beginning of the talk. So you mentioned this idea that often we see duration effects because essentially we're trying to slow down to give ourselves more time to process the ordering of the phonemes in the word. So am I right in thinking that this essentially gives us the prediction that we should see duration effects of smaller magnitude when we look at slower speech relative to faster speech?
Mm-hmm. I think
so.
I think that's right.
Okay, thanks.
Oh, that was easy.
Yeah, like I said, it was a quick question, just a quick clarification.
I think that's right. I mean, I think, like, when I think about sort of speech rate and phonological encoding, like Gary Dale has this sort of nice analogy. Like I gave this version of this, presented this work to him, and he's like, it's kind of like a spelling bee, where, you know, you have a long word that like football, you know, it doesn't take much time to kind of get started with it. But if you're asked to spell onomatopoeia, you may know how to spell it, but you're going to slow down in sort of the selecting of each of those letters, because you just need time to do the accessing because it's a harder word. And so the same kind of thing is sort of playing out in speech. I think that when you have these more difficult words, you sort of slow down to give yourself time to access. And if the overall speech rate is slow, then maybe you don't have to slow down as much. So I think that's a reasonable prediction. I'd be curious to see if that's actually true.
So in my cursory knowledge of the literature, which is fairly cursory, it suggests that we still see those effects in artificially slowed speech, or in cases where people are speaking clearly, like with a hard of hearing interlocutor, for example. Although I don't know the extent to which the magnitude of those effects is different. And then, of course, as you've taken a lot of pains to point out, I think that there are many different effects on duration, and so many of those could probably be attributable to other processes. But yeah, I think that would be a really interesting thing to try to figure out, like, to the extent to which we actually know if this is true or not.
Yeah, absolutely. Is it Johannes?
Yeah, Johannes. I just wanted to follow up on Rory's question, kind of, because I was really intrigued by the initial part as well. So you were talking, there's two different types of perspective to look at the problem of duration. It's either because of the planning, so speaker oriented, or addressee oriented in terms of the effects. Now, I've worked on pitch duration and pitch height. And I was wondering, basically through the first part of your studies that you reported, how do you know that this is actually duration that is being measured? Like, how do you know that this is really the thing that you're measuring, rather than the speaker, rather than the interaction between, for example, pitch, accent, and duration? Because there's a number of studies who've looked into this, and I can never really tease apart what they're trying to say. And is this really, can we actually measure whether this is speaker oriented or addressee oriented?
Yeah, that's a great question. I mean, I guess I think this is sort of duration rather than sort of maybe the form of the pitch accent driving the duration. That's sort of the alternative, because in these repetition tasks, like you know, the layover layout experiments, people aren't. I mean, I don't know that there's much of a discourse structure or much sort of pitch accenting being produced, other than the kind of pitch accent you might produce sort of just spitting out a list of words. But most importantly, there's no reason to think that they differ by condition, right? And even in our sort of shrink flash experiments, we're looking at the same phrase, you know, the beetle shrinks or the beetle flashes. And so there's not, I don't know that there's a reason to think that there might be pitch accent differences, or at least discourse differences that would drive those pitch accents. There might be, you know, because we didn't really control for that. But I suspect that, at least for what we're looking at, this is probably duration. I don't know if I put money on it, but I think I'm fairly confident.
Yeah, would have been my impression too. It's just so difficult to actually prove that this is really only duration rather than anything spilling into duration. But that middle part where you talked about, for example, pitch height, intensity, and duration. So if you really look into those proportions, you might actually be able to tell in a little bit more detail.
Yeah, thanks. It's a good suggestion. Nick?
Yeah, great. Thanks for a great talk. Did you notice anything interesting regarding individual differences? Because there are individual differences in perception and production of prosody across different populations. I'm thinking in particular of autism. So, for example, were there any individuals who didn't show any differences across the two contexts in terms of what was it, word length or pitch?
Yeah, that's a great question. I think there probably were differences, but we didn't design the experiment to really look at them. We're running, and I say we didn't design it, we didn't sort of run enough subjects, and I think didn't think sort of intentionally enough about how to sort of best pull out individual differences if they were there. We are running a study now looking at whether overlap depends on sort of your own dialect, whether you get overlap in your dialect or not. So in the southern US and in the southern US, you have this pen merger. It's merged for me, and so I can't actually produce the different ones. So we have a lot of southern speakers here, but we also have a lot of northern US, western US speakers in Nashville as well. And so we're interested in whether if you get overlap, that would be overlapping in your dialect, but not in the speaker's dialect, does that drive duration differences or vice versa? And it looks like it does. Like you kind of have this sort of abstract representation that seems to drive the same kind of overlap effects that you would. But that's the only kind of individual difference that we've looked at so far. It would be super interesting to look at populations like folks with autism to see what kind of differences there are in production. We've done some studies. I have a collaborator at the medical center here where we've done sort of perception experiments with adolescents with autism. And we've done sort of production experiments and sort of perception experiments, and find that for the production side, they, at least in sort of very simple tasks, they produce very similar prosody, at least in the way that we're measuring it, although when you hear it, it sounds different. And they perceive prosody very similarly to typical adolescents, but are just a bit slower at processing the signal. So there are these sort of differences, but I don't feel like I know enough to sort of characterize them quite yet.
Yeah, I'm not up to date with the literature, and when one does find a difference between populations, you have quite a strong publication bias towards claiming that there is a difference. So probably what you're finding is a lot more subtle than the kind of typical claims in the literature. Right. Yeah.
All right, Lauren?
I know that we probably need to wrap up soon, but is there a very quick overview of the third section that you skipped that you could give?
Yes. So basically, in that experiment, there's an assumption in the prosody literature that when we hear things like intonational boundaries or pitch accents, it's driven by the signal itself. And so we were interested in whether, if there's a lot of reason to think that there's an intonational boundary at a location, say it's a big syntactic boundary, will people report hearing it with minimal to no acoustic evidence? And the answer is yes. In fact, when there's no cues when we sort of resynthesize the speech so that there are no cues to an intonational boundary, people say, yes, there is one. And this is interesting to me because it suggests that, so prosody researchers use like Toby coding, various different types of perceptual coding to indicate whether there's a prosodic event. And if our expectations are partly guiding our perception, that is worrisome to me. So that's basically the thrust of it, that there's lots of top-down processing and perceiving prosody. And we weren't the first to show that. There's work by Jennifer Cole and Jason Bishop showing some very similar things. Thanks for that question. Well, thank you for having me. If there's no other questions, it's a lot of fun.
Yeah, thanks for doing this, and you know, glad we were able to make it work. So let's thank our speaker again and let him get on with his afternoon.
That was really interesting. Thank you.
Thanks.
That was fantastic, Duane.
Thank you.
Thank you.
Thanks very much.